Good afternoon, one and all. I myself Alkka from ECE department, and today I am here in front of you during this TechTalk event to present a topic which has high relevance in wireless communication area, that is cognitive radio networks. And the outline of the topic includes what is or the introduction to cognitive radio network, objectives of cognitive radio network, what is CR network architecture, main issues in cognitive radio network, what is CRN standards, cognitive radio platforms, future research directions, and conclusion. Let us go to the introduction section. Introduction to cognitive radio network. A cognitive radio can be defined as a software radio or an intelligent radio, and its main principle is to sense the spectrum which has not been efficiently used in the electromagnetic spectrum, and that spectrum has been identified by the cognitive radio, and it can be used very efficiently for the communication purpose. And it is a radio that automatically detects available channels in wireless spectrum, accordingly changes its transmission or reception parameters to allow more concurrent wireless communication in a given spectrum band. And the cognitive radio assigns spectrum to two users mainly. First one is primary user, second one is secondary users. And the primary users hold licensed holds. Secondary users, it has no spectrum license. Next, the figure depicts the relation between power and time. It mainly gives an idea about how the dynamic spectrum access is done. And the cognitive radio technology works on the principle of dynamic spectrum access, where secondary users utilize the spectrum holes. Spectrum holes are the spectrums which are not used in the wireless communication. That is the spectrum which has been sitting in the ideal manner. That is known as spectrum holes. And a spectrum hole is a band of frequency assigned to a primary user, but at a particular time and specific geographic location, the band is not utilized by that user. Next, how is cognitive radio different from other radios? The conventional radio means it supports a fixed number of systems. Reconfigurability decided at the time of decision, may support multiple services but chosen at the time of decision. Software radio, it dynamically supports multiple variable systems, protocols and interfaces, interface with diverse system, and provides a wide variety or wide range of services with variable quality of service. Next is cognitive radio. It can create new waveform on its own and can negotiate new interfaces, adjust operations to meet the quality of service required by the application for the signal environment. And the main objectives of cognitive radio network includes the following: spectrum sensing, spectrum decision, spectrum sharing, spectrum mobility, etc. Spectrum sensing means it determines the spectrum holes, that is the spectrum that remains ideal in the electromagnetic spectrum. Spectrum decision means it selects the best spectrum opportunities to meet the user communication requirement. Spectrum sharing means it coordinates access to the selected channels with cognitive radio neighbors. Spectrum mobility means it switches to the selected opportunities and maintains seamless communication during spectrum handover. And the cognitive radio network also avoid any harmful interference to primary users. This picture gives a clear idea that is, it involves all the objectives of cognitive radio networks. Next, the picture depicts cognitive radio network architecture. The picture consists of licensed as well as unlicensed spectrum band and divides into two users. First one is primary user, second one is secondary user. The secondary users network with infrastructure and secondary network without infrastructure. All these are given in this diagram. Next, CRN architectural approaches. The architecture of cognitive radio has been divided into mainly two types. First one is centralized one, second one is distributed one. In the case of centralized approach, the spectrum allocation and access are completely controlled by a central entity. The central entity is the base station. In the case of distributed approach, the spectrum allocation and the access is completely controlled by a cognitive radio users. Next, the main issues that comes in cognitive radio networks. There are 5 issues. First one is self-coexistence. That is, the cognitive radio is used to avoid secondary users to harmfully interfere with primary users. Next is accurate sensing. Sensing aims to determine if a channel is ideal or busy. Signaling means it uses a common control channel which facilitates signaling. Next is optimized spectrum decision. Secondary users are expected to dynamically choose the best available channels. Next is seamless spectrum handover. That is, transmission is carried out with minimum quality degradation. All these are the main issues in cognitive radio networks. Next, CRN standard. The IEEE 802.22 standard is the first effort for achieving the cognitive radio international standard, and it defines CRN techniques that are specifically targeted to enable unlicensed devices to exploit television white spaces in the VHF and UHF bands. Next, the platforms used in cognitive radio networks. Wireless Open Access Research Platform, which is defined as WAP, SORA, Cognitive Radio Learning, and Berkeley Emulation Engine. All these are platforms used for cognitive radio. Next, future research directions. Seamless spectrum handovers, proactive spectrum selection and interference avoidance, interdependency between the propagation characteristics of radio signals and the frequency band in usage, alternatives to common channel, energy efficiency, validation of the cognitive radio protocols. And hereby I conclude my session of cognitive radio network technology. And in short, we can define that a cognitive radio has a software or a programmable radio which can be used in electromagnetic spectrum to sense the spectrum which is not efficiently utilized, and that spectrum can be efficiently utilized for wireless communication. That is the spectrum which remains ideal. This is the main technology behind cognitive radio, and here it provides readers a global vision of cognitive radio concerning its principles and possible future directions.